So, hello everyone. Welcome back to my YouTube channel. My name is Nandini, and I scored 632 out of 720 in NEET 2024 examination, and currently I'm preparing for NEET 2025. So, in this video, I'll be reading the chapter 10 of class 12 chemistry uh, mm, book, that is biomolecules. So, we all know that it is a theoretical chapter, and we tend to become lethargic when it comes to reading the chapter from NCERT. So I am here with you all to save your time, as well as provide you with the reading of this chapter and also the important points I highlight along with. So without any further wastage, let's get into the video. So, Unit 10, Biomolecules. It is the harmonious and synchronous progress of chemical reactions in body which leads to life. A living system grows, sustains, and reproduces itself. The most amazing thing about a living system is that it is composed of non-living atoms and molecules. The pursuit of knowledge of what goes on chemically within a living system falls in the domain of biochemistry. Living systems are made up of various complex molecules like carbohydrate, protein, nucleic acid, lipids, etc. Protein and carbohydrates are the essential constituent of our food. So we have an important line over here, that protein and carbohydrate are the essential constituents of our food, not fats. So keep that in mind. Okay. So okay, sorry. Uh-huh. These biomolecules interact with each other and constitute the molecular logic of life processes. So they need to these biomolecules interact with each other and constitute the molecular logic of life processes. In addition, some simple molecule like vitamin and mineral also play an important role in the function of organisms. So, in addition, some simple molecule like vitamin and mineral salt also play an important role in the function of organisms. Structures and functions of some of these biomolecules are discussed in this unit. Topic 10.1, carbohydrates. Carbohydrates are primarily produced by plants and forms a very large group of naturally occurring organic compounds. Some common examples of carbohydrates are cane, sugar, glucose, starch, etc. Most of them have a general formula of CxH2O whole Y and were considered as hydrates of carbon, from where the name carbohydrate was derived. For example, the molecular formula of glucose is 6,6H12O6, fit into this general formula C6H2O whole 6. But all the compound which fit into this formula may not be classified as carbohydrate. For example, acetic acid fits into this formula C2H2O whole twice, but it is not a carbohydrate. We all know that. Similarly, rhamnose C6H12O5 is a carbohydrate, but does not fit in this definition. A large number of their reactions have shown that they contain specific functional groups. Chemically, the carbohydrates may be defined as uh, optically active polyhydroxyaldehyde or ketones. Optically active polyhydroxyaldehydes or ketone are the compounds which produces such units on hydrolysis. Some of the carbohydrates which are sweet in taste are also called sugars. Okay, sugars. The most common sugar used in our home is the sucrose, whereas the sucrose is a non-reducing sugar. Very important line. Whereas the sugar present in the milk is known as lactose. We all know that. A carbohydrate also called saccharides, that means sugar. Carbohydrates are also called saccharides. Okay, Greek word saccharons, this is derived. Now topic 10.1.1, carbohydrates are classified on the basis of their behavior on hydrolysis. They have been broadly divided into the following three groups, that is monosaccharide, oligosaccharide, and polysaccharide. So monosaccharide, a carbohydrate that cannot be hydrolyzed further to give simpler unit of polyhydroxyaldehyde or ketone, is called a monosaccharide. Okay, it cannot be hydrolyzed further. About 20 of them are known to occur in nature. Very important number. 20 of them are known to occur in nature. Some common examples are glucose, fructose, ribose. These are all monosaccharides. Moving forward to oligosaccharides, carbohydrates that yield 2 to 10 monosaccharide units. Very important. 2 to 10. 2 to 10 monosaccharide units on hydrolysis are called oligosaccharides. They are further classified as di, tri, tetra, etc. Depending upon the number of monosaccharides they provide on hydrolysis. Amongst these, the most common are disaccharides. The two monosaccharide units obtained on the hydrolysis of a disaccharide may be same or different. So it is important that it may be same It may be same or may be different also. For example, one molecule of sucrose on hydrolysis give one molecule of glucose and one molecule of fructose, whereas maltose give two molecule of only glucose. So this is a true statement. Okay. Now moving ahead to the polysaccharides. Carbohydrates, which yield a large number of monosaccharide unit on hydrolysis, are called polysaccharides. Some common examples are starch, cellulose, glycogen, gums, etc. Polysaccharides are not sweet in taste. Very important line. Polysaccharides are not sweet in taste. Okay, saccharides are sweet in taste. That is why they are also known as sugar. Okay, so carbohydrates are also known as saccharides, which means sweet. We read it upar, na? Saccharon means sugar, but the thing is that polysaccharides are not sweet in taste. Monosaccharides are sweet in taste, because we saw here the most common sugar which we use in as sucrose is a disaccharide, so it comes under oligosaccharide. So that is so obviously sweet in taste, but polysaccharides are not sweet in taste. That we need to keep remember. Hence, they are also called non-sugars. Okay, so polysaccharides are called non-sugar. Okay. The carbohydrate may also be classified as either reducing or non-reducing. All those carbohydrates which reduce Fehling and tolerance reagent. Fehling A and Fehling B, you all know. Fehling A is aqueous copper sulfate and Fehling B is that sodium Rochelle salt, potassium tartrate or something like that, Rochelle salt, and tolerance reagent is ammonical silver nitrate, are referred to as reducing sugars. All monosaccharide, whether aldose or ketose, are reducing sugars. Very important. All monosaccharide, whether aldose or ketose, are reducing sugars. Monosaccharide में glucose, fructose comes. Okay, so these are all reducing sugar except for sucrose, which is a disaccharide. Now, monosaccharide are further classified on the basis of number of number of carbon atoms and the functional group present in them. If a monosaccharide contains an aldehyde, it is known as an aldose, and if it contains a ketone, is known as a ketose. Number of carbon atom constituting the monosaccharide is also introduced in the name as it is from the example in table 10.1. Okay, so this is the very basic. Now moving ahead, 10.1.2.1, which is glucose. So glucose occurs freely in nature as well as in the combined form. It is present in the wait a second, just let me is freely in nature as well as in the combined form. It is present in sweet fruits and honey. Ripe grape also contain glucose in large amount. It is prepared as follows. Okay, preparation of glucose from sucrose, which is the cane sugar. Sucrose is the cane sugar. If sucrose is boiled with dilute HCl or H2SO4, so dilute HCl or H2SO4 in alcoholic solution, very important, not basic. Glucose and fructose are obtained in equal amount, not unequal amount. This is a question from AIMS previous year. It is not unequal, it is equal amount. Sucrose is dextrorotatory, but like sucrose gives glucose plus fructose, and sucrose is dextrorotatory, but glucose is but fructose is levorotatory. So when the hydrolysis takes place, sucrose gets converted into glucose and fructose is levorotatory. So inversion of cane sugar occurs, and this dextrorotatory changes to levorotatory in the aqueous solution. So you need to keep in mind. Okay. So dilute HCl, H2SO4 and alcoholic equal amount में we get glucose and fructose. Here it is the equation is given. C12H22O11 is sucrose, glucose and fructose. Okay, both are the same formula, but here it is aldehyde in glucose and it is ketone in fructose. Now from starch. So commercially glucose is obtained by the hydrolysis. So important point is commercial. Glucose is obtained by the hydrolysis of starch by boiling it with dilute H2SO4 at 393 Kelvin under pressure. So commercial preparation of glucose is from starch and not sucrose. Hydrolysis by boiling it with dilute H2SO4 at 393 Kelvin under pressure. Okay, 393 Kelvin. Okay, 273, 373 is the boiling point of water. Starch or cellulose. Okay, cellulose is also a polymer of glucose and starch is also a polymer of glucose, and commercially it is prepared by hydrolysis of starch. Okay, now structure of glucose. Glucose is an aldohexose, I told it, and it is also known as dextrose. So it is aldohexose and also known as dextrose. It is a monomer of many of the larger carbohydrates, namely starch, glucose. It is probably the most abundant, very important, most abundant organic compound on earth. It was assigned the structure given below on the basis of the following evidences. So this is the structure. This is the structure of glucose. Okay, and it was assigned the structure given below on the basis of following evidences. Its molecular formula was found to be C6H12O6. On prolonged heating, which HI is a reducing agent, it forms N-hexane. Okay, all the bonds are broken and H is given to all of them, suggesting that all the 6 carbon are linked in a straight chain. So N-hexane is formed with HI on heat because HI is a reducing agent. Now, glucose reacts with hydroxylamine. Hydroxylamine is NH2OH group. So glucose reacts with hydroxylamine to form an oxime and adds a molecule of hydrogen cyanide to the given to give cyanohydrin. When it reacts with HCN, it gives cyanohydrin, and when it reacts with hydroxylamine, it gives oxime. NH2OH is hydroxylamine, so it gives oxime. Structure is given there, and this is cyanohydrin. This reaction confirms the presence of a carbonyl group in glucose. So which reaction confirms the presence of a carbonyl group? That is the reaction with cyanohydrin and hydroxylamine. Now, glucose gets oxidized to 6-carbon carboxylic acid, which is gluconic acid. Okay, glucose gets oxidized to 6-carbon carboxylic acid. Carboxylic acid, you can see this is carboxylic acid, COH group, and this is gluconic acid. So glucose gets oxidized to 6-carbon carboxylic acid, which is gluconic acid, and not saccharic acid. Saccharic acid is with concentrated HNO3 on reaction with a mild oxidizing agent. Mild oxidizing agent is bromine water as a mild oxidizing agent. This indicates that the carbonyl group is present. The carbonyl group is present as an aldehyde group and not ketone. So it is an important reaction. Like the question may be asked, like which reaction confirms that the carbonyl group is present as an aldehyde and not ketone. So it is the mild oxidizing agent like bromine water. Okay, so gluconic acid is produced. Now, acetylation of glucose with acetic anhydride gives glucose pentacetate. Okay, which confirms the presence of 5 OH groups. So question might be asked that which reaction tells about the presence of 5 OH groups. That is acetylation of glucose with acetic anhydride, which gives glucose pentacetate, which confirms the presence of 5 OH groups. Since it exists as a stable compound, 5 OH groups should be attached to different carbon atoms. Okay, acetic anhydride, you must be knowing it, like CH3, C double bond O, C double bond O, CH3. This is acetic anhydride. So 4 are there and 5th is here. So all the OH are replaced by this group. Okay, moving forward. Okay, on oxidation with nitric acid, I said earlier also, with nitric acid it gives saccharic acid as well as gluconic acid. Glucose as well as gluconic acid both yielded dicarboxylic acid, saccharic acid. So saccharic has double C. So remember like that, if there are two COH groups, then it will be a saccharic acid because it has 2 C's. This indicates the presence of a primary alcoholic group in glucose. So, wait a minute. Question might be asked in this way, that on oxidation with nitric acid, glucose presence of a primary alcoholic group is confirmed by the reaction with HNO3. Okay, on oxidation of like gluconic acid, you have COH here and here it is CH2OH, but when it is oxidized, here also COH and here also COH. So you need to keep in mind. Okay, the exact spatial arrangement of different OH group was given by Fischer after studying so many other properties. Its configuration is correctly represented as 1. Okay, so this is glucose, this is glucose. Okay, so gluconic acid is represented as 2. So gluconic acid has only 1 COH and saccharic has 2 COH. I hope it's clear. Now, glucose is correctly named as D plus glucose. Okay, D plus glucose. D before the name of the group is the configuration, whereas plus represent the extra nature of the molecule. This is also a previous question of Ames, I guess. Okay, D represents the dextrorotated nature, but it is not like that. D just represents the configuration. Okay, so if you see here in the second last carbon, OH is on the right side, so that is because like that is represented by D. Okay, now it should be remembered that D and L have no relation with the optical activity. Very important line. It should be remembered that D and L have no relation with the optical activity, which is L, matlab dextro and levo. They are not related to letter D and L as well. The meaning of D and L notation is as follows. What is it? Let's read. The letter D or L before the name of any compound indicate the relative configuration of a particular stereoisomer of a compound with respect to the configuration of some other compound, configuration of which is known. In the case of carbohydrate, this refers to the relation with a particular isomer of glyceraldehyde. Very important. In case of carbohydrate, the reference is made with respect to glyceraldehyde. Contain one asymmetric carbon and exist in two enantiomeric forms as shown. So this is glyceraldehyde, plus and minus. Okay. So this is dextro and this is levo, and this is glyceraldehyde, CH2OH, CH2H, CHO, CHO, and one OH on the left and right on, and here it is on the left side. Now, plus isomer of glyceraldehyde has D configuration. Okay, it means that when its structural formula is written on the paper following specific convention which you will study in higher classes, the OH group lies on the right hand side in the structure. Okay, so plus has D configuration, and D configuration means OH on the right side. All those compounds which can be chemically correlated to D isomer of glyceraldehyde are said to have D configuration, whereas those which can be correlated to the L isomer of glyceraldehyde are said to have L configuration. In L isomer, OH is on the left side, as you can see in the structure. Okay, so okay, this is the L, this is the L. I need to clear this. This is the L form. Okay, and this is the L form, and OH is on the left side. So that's only the thing, like here it was written. Okay, for assigning the configuration of monosaccharide, it is the lowest asymmetric carbon atom as shown below, which is compared. Okay, so for assigning the configuration of monosaccharides, as in glucose, it is the lowest asymmetric carbon. Asymmetric is the chiral carbon, which is compared. As in glucose, OH on the lowest asymmetric carbon is on the right side, which is compared to the plus glyceraldehyde. So plus glucose is assigned D configuration. Other asymmetric carbon of atom of glucose are not considered for this comparison. Also, the structure of glucose and glyceraldehyde is written in a way that most oxidized carbon is at the top. What does this mean? Let's read it once again. That it is the lowest asymmetric carbon atom, which is compared. Okay, lowest. Highest is given to the CHO group, है ना? Which is compared lowest is on the right side, which is compared to the plus is assigned to the other asymmetric carbon atom of glucose are not considered for this comparison. Also, the structure of glucose and glyceraldehyde is written in a way that most oxidized carbon CHO is the top. So this is the most toppest, sorry, not toppest, the most highest, and here is the lowest asymmetric, and OH is on the right side. So this is plus glucose and this is plus glyceraldehyde. Okay, so yeah, it's clear now. Cyclic structure of glucose. Now the structure of glucose explained most of its property, but the following reactions and factors could not be explained by the structure. Despite having the aldehyde group, glucose does not give Skiff's test, and it does not form the hydrogen sulfide addition product with NaHSO3. Okay, so we are studying the cyclic structure of glucose, and what were the reasons? Because it is having an aldehyde group but still not giving Skiff's test, and also do not form the hydrogen sulfide addition product with NaHSO3. Okay, the pentacetate of glucose does not react with hydroxylamine, indicating the absence of free CHO group. Okay, so free CHO group is not present. Glucose is found to exist in two different crystalline forms, which are named as alpha and beta. Okay, glucose is found to exist in two different crystalline forms, which are named as alpha and beta. The alpha form of glucose melting point is obtained by the crystallization from concentrated solution of glucose at 303 Kelvin, while beta form, which is much higher boiling point of 423, is obtained by the crystallization from hot and saturated aqueous solution at 371 Kelvin. Okay, so alpha has lower melting point, beta has higher boiling point, and it is obtained at lower temperature, and crystallization from hot and saturated aqueous solution is at a higher temperature. Okay, this behavior could not be explained by the open chain structure of glucose. It would propose that one of the OH group may add to the CHO and form a cyclic hemiacetal structure. So cyclic hemiacetal structure. It was found that one It was found that glucose forms a six-membered ring in which OH at C5 is involved in a ring formation. OH at C5 is involved at a ring formation. Here, OH of this position is involved in the ring formation. Okay, this explains the absence of CHO group and also existence of glucose in two forms shown below. These two cyclic exist in equilibrium. These two cyclic form exist in equilibrium with the open chain structure. So this is the sign for equilibrium. This is the sign for equilibrium. Okay, and these two cyclic forms, which two? These and these exist in equilibrium with the open chain structure. So this is the open chain structure, if I'm not wrong. And this is the fifth carbon. Okay. Now moving ahead. The two cyclic hemiacetal forms of glucose. So two cyclic hemiacetal form of glucose differ only in the configuration of the hydroxyl group at C1 position, called anomeric carbon. Okay, anomeric carbon. So if we see the difference in them, so they only differ C1 position pe. Okay, you can see here. Okay, you can see here that OH is on the right side and here it is on the left side. So left side, that is why left side it is. So this is beta form and this is alpha. D is constant because OH is on the right side. But this is beta and this is alpha on the right and beta on the left. And they are called anomeric carbon, differing only at C1 position. Okay, so, okay. The aldehyde carbon before cyclization, anomeric carbon, which is the aldehyde carbon before cyclization. Such isomers, that is alpha form and beta form, are called anomers. Okay, anomer, C1 anomer. Six-membered cyclic structure of glucose is called pyranose structure. Okay, not furanose. Furanose is for fructose. Pyranose structure, which is the six-membered cyclic structure, alpha or beta in analogy with the pyran. Okay. Pyran is a cyclic organic compound with one oxygen atom and 5 carbon atom in the ring. The cyclic structure of glucose is most given by the Haworth structure is given below. Haworth structure. Okay. This. Okay. This is the pyran ring, and this is alpha, and this is beta. Beta pe OH is on the upper side. Okay, and alpha mein OH is on the lower side. Okay, and this is glucopyranose. Obviously 5 carbon atoms, 1 2 3 4 5 in the ring and 1 oxygen in the ring. So this is the pyran ring. Okay, now coming to fructose. 10.1.2.2. Fructose is an important ketohexose. Glucose was an aldohexose and fructose is a ketohexose. It is obtained along with the glucose by the hydrolysis of a disaccharide, which is sucrose. Okay, it is a natural monosaccharide found in fruit, honey and vegetable. Fruits mein fructose is there. In its pure form, it is used as a sweetener. It is also an important ketohexose, and in its pure form, it is used as a sweetener. Okay, structure of fructose. Fructose also has a molecular formula C6H12O6, and on the basis of its reaction, it was found to contain a ketonic functional group and at carbon number 2 and 6 carbon in straight chain. As in the case of glucose, it belongs to D series and is a laboratory compound. It is appropriately written as D minus fructose. Glucose was dextrohereditary. It is open chain structure as shown. This is the open chain structure for fructose. Okay, it also exists in two cyclic form which are obtained D minus fructose by the addition of OH at the C5. So as I was saying that it also exists in two cyclic form which are obtained D fructose by the addition of OH at C5 to the COO group. So you can see here that the C5 wala carbon is getting attached to the second wala COO group. The ring this formed is a 5-membered ring and is named as furanose, which is wait a minute. So the ring thus formed is a 5-membered ring and is named as furanose. So in glucose it was pyranose. With an analogy to the compound furan, furan is a 5-member cyclic compound with 1 oxygen and 4 carbon atom. So 4 carbon atom, 1 2 3 4 and an oxygen atom. Okay, so this is alpha D fructofuranose and this is beta D fructofuranose. Okay, OH is here and OH is here. Beta में the OH is on the right side. नहीं, beta में it is on the left side and alpha में it is on the right side. The cyclic structure of two anomers of fructose are represented by the Haworth structure as given. Okay. Cyclic structure of two anomers of fructose are represented by the Haworth structure. Alpha D fructofuranose, beta D fructofuranose. Beta में OH is on the upper side and alpha में OH is on the lower side. These are also anomers. Okay. Moving forward, disaccharides. So in this video I'll be covering only carbohydrates because it is in itself a very long portion, okay, and constitute the maximum portion of the chapter. So disaccharide, you have already read that the disaccharide hydrolyzed with dilute acid or enzyme yield two molecule of either the same or the different monosaccharide. The two monosaccharides are joined together by an oxide. The two monosaccharides are joined together by an oxide linkage formed by the loss of a water molecule. So the two monosaccharides are joined together by an oxide linkage formed by the loss of water molecule. Such a linkage between the two monosaccharide units through oxygen atom is called glycosidic linkage. In disaccharide, if the reducing group of monosaccharide, that is aldehyde or ketonic, are bonded, these are non-reducing sugars. In disaccharide, if the reducing group of monosaccharides, such as aldehyde or ketonic group, are bonded, these are non-reducing. Example, sucrose. On the other hand, sugar in which these functional groups are free are called reducing. For example, maltose and lactose are reducing. Only non-reducing given in NCERT is sucrose. Okay, one of the common disaccharide is sucrose. And which on hydrolysis give equimolar mixture of glucose and fructose. Equimolar aims PYQ that it is like unequal. So no, it is equimolar glucose and fructose. Fructose is levorotatory and glucose is dextrorotatory, and sucrose is also dextrorotatory. These two monosaccharides are held together by glycosidic linkage between C1 of alpha D glucose and C2 of beta D fructose. Since the reducing group of glucose and fructose are involved in glycosidic bond formation, sucrose is a non-reducing sugar. Why is it non-reducing? Because the reducing group of glucose and fructose, which is the aldehyde and glucose and fructose is ketone, are involved in glycosidic bond formation. C1 of alpha D glucose and C2 of beta D fructose. Moving forward, here you can see that glycosidic linkage is present by the loss of water molecule. C2 of fructose, this is 1 2 3 4 5 shaped, and this is 1 2 3 4 5 6 membered. Alpha D glucose, beta D fructose, C1 of alpha and C2 of fructose. Now this is also PYQ, this whole diagram. Sucrose is dextro, but after hydrolysis give dextro glucose and levofructose. Since the levorotation of fructose is more than dextro of glucose, is the mixture is levo. Thus hydrolysis of sucrose brings about change in the sign of the relation from dextro to levo, and the product is named as invert sugar. I am telling you from that time only. Okay. Now maltose is another disaccharide. Maltose is composed of 2 alpha D glucose. 2 alpha D glucose is maltose. 2 alpha D glucose, in which C1 of one glucose is linked to the C4 of another glucose. So C1 to C4 linkage is present. C1 of one is linked to C4 of another unit. The free aldehyde group can be produced as a C1 of second glucose. In solution, it shows reducing property, so it is a reducing sugar because this CHO is free of the other one. Where is it? Alpha D glucose. Here, what is it saying? Maltose is composed of 2 alpha D glucose unit, in which C1 of one glucose molecule, C1 of one, is linked to the C4 of another. The free aldehyde group can be produced at C1 pe of the second glucose in solution and show reducing property, so it's a reducing sugar. Okay, so maltose is reducing, sucrose is non-reducing. Moving forward, lactose, commonly known as milk sugar. Lactose, since this is a disaccharide found in milk, it is composed of beta D galactose and beta D glucose. So lactose is glucose plus galactose, and both of them are beta D. The linkage is between C1 of galactose and C4 of glucose. Very important. C1 is of galactose and C4 is of glucose. Free aldehyde group may be produced as C1 of glucose because we are using C4 of glucose. So one carbon is free, the position at one first position. So it is also reducing sugar because free aldehyde group may be produced at the C1 of the glucose unit. Okay, so here a diagram is given. Here the diagram is given. So this is galactose and this is glucose. Glucose का fourth carbon and galactose का first carbon. Okay. Now polysaccharides. Polysaccharides 10.1.4 polysaccharide contain a large number of monosaccharide units joined together by glycosidic linkages. So glycosidic linkage is present in carbohydrate. These are the most commonly encountered carbohydrate in nature. Most commonly encountered. They mainly act as food storage or structural material. Okay, starch, very important polysaccharide. Starch is the main storage polysaccharide of plants. So we know that in plants, the food is stored in the form of starch. So it is the main storage polysaccharide of plants. It is the most important dietary source of human beings. High content of starch is found in cereal, root, tuber, and some vegetables. It is a polymer of alpha glucose and consists of two components, amylose and amylopectin. Amylose is water soluble. Which constitutes about 15 to 20% of starch. Chemically, amylose is a long, unbranched chain with 200 to 1000 alpha D glucose units held together by C1C4 glycosidic linkage. C1C4. Okay, it is present in amylose, and amylopectin is insoluble because it, like, see, I can remember, like, you can remember it in such a way that amylopectin is a long word, so it is insoluble and constitute about 80 to 85% of starch because it is a long word. It is the longer one, like amylose and amylopectin is the longer one, so it will constitute more of the starch. And it is a branched chain also of alpha D glucose, in which the unit is formed by C1C4 glycosidic linkage, whereas branching occur at C1C6 glycosidic linkage. Okay, so that is all about amylose. See, this is the structure for amylose. C1C4 linkage is seen over here, है ना? C1C4 linkage is there, and amylopectin में branching हो जाती है, branching at C6, alpha linkage of C1C4 and branching at C6. So this is amylopectin, 80 to 85%. Okay. So now coming to cellulose. Cellulose occur exclusively. Cellulose, plant का cell wall, very basic. Plant का cell wall is made of cellulose extensively in plant, and most abundant organic, okay, very important, and most abundant organic substance in plant kingdom. Most abundant organic substance in plant kingdom is cellulose, and it is predominant present on the cell wall of the plant cells. I already told. Cellulose is a straight chain polysaccharide composed only of beta D glucose. Okay, so which are joined by glycosidic linkage between C1 of one glucose and C4 of the next glucose unit. So remember that. Now glycogen, the carbohydrate are stored in the animal body as glycogen. Very like basic thing, that they are stored in animal body as glycogen, also known as animal starch, because its structure is similar to amylopectin and is rather more highly branched than amylopectin. Okay, it is present in liver, glycogen, muscle and brain. When the body needs glucose, enzyme break the glycogen down to glucose. Glycogen is also found in yeast and fungi. So statement may come, glycogen is found in yeast and fungi also. Okay, so now the last topic, I guess, 10.1.5, which is the importance of carbohydrate. They are essential for life in both plants and animals. They form a major portion of our food. Honey has been used for a long time as an instant source of energy by Veds and Ayurvedic system of medicine that contains carbohydrate, and they are also used as storage molecules as starch in plant, glycogen in animals. Cell wall of bacteria and plant is made up of cellulose. We build furniture, etc. from the cellulose. In the form of wood and clothe ourselves with cellulose in the form of cotton fiber. They provide raw material for many important industries like textile, paper, lacquers, and breweries. 2 aldopentoses, that is ribose and 2-deoxyribose, okay, are present in nucleic acid. Very important. Carbohydrates, So these are the sugar which is present in the nucleic acid. We all know that ribose and deoxyribose. And nucleic acid, carbohydrate are found in biosystem in combination with many protein and lipids. Okay. Finally. So in this video we'll keep it till here only. In the next video I'll come up with protein, nucleic acid, vitamins, enzymes, and hormones. So carbohydrate in itself is a large portion. So I hope that you got all the points and you were able to catch up along with me in the chapter. So meet you in the next video. Till then, keep studying hard. And for more such content, please subscribe to my channel. It really motivates me to make further videos. So please consider subscribing my channel. I really want to hit 1000 subscribers soon. So if you found this video helpful, then do like, share, and subscribe. Thank you.